Is about to answer the questions, proving questions. Okay, the question is about show the cosine x is analytic for all real x. In order to answer the questions, we have to know the basic equations for cosine x. Like we have learned before in Taylor's series, we can write cosine x in the form of 1 minus x squared over 2 factorial plus x4 factorial minus, and it's a series and continuously. And then we can write this one in the form of summation, n equal to 0 to infinity, and it's -1 n divided 2n factorial x to n. Alright, so we have done the cosine x in the form of summation, and in order to answer the questions here, analytic for all real x, we have to compare the summation form for cosine x with the general power series. So the power series, so general, is in summation x minus x naught n. And we can see here the cosine x is actually, we apply the x naught equal to 0. So our power series turned out to be x to the power of n. And then we compare the power series, the general power series, with the cosine x. This one. Right, from here we can see that our an is actually this one. Right, and we need to use this one in order to show the analytic for all real x. So now we have our en. Okay, for the analytic, we have to show that our radius of convergence which is a rho equal to 1 over L is equal to infinity, to show that this cosine x is analytic for all real x. So our target is to show that the rho is equal to infinity. So in order to have the rho, we have to know the L, because rho is basically a reciprocal of L function. And our L is defined as a limit and approaching to infinity for an plus 1 an. Okay, we have our an here, the general, so we just write it. For the first one is -1 n plus 1 over 2n plus 2 factorial. Then we divide by the an here, -1 n over 2n factorial. Okay, we have to solve this one first to show that to get the L function. So this one is divide, so we have to change it into multiplication. So we have, I split this, later you guys will know the reason why I split this. It's -1 over 1, 2n plus 2 factorial divided by 2n factorial, -1 over n. This is the reason why I split, because we can cancel the power of n here. And to solve the factorial part, I will show you it here. We have a 2n factorial divided by 2n plus 2 factorial. Basically, we can write the factorial in the form from 1 times 2 times 3 up to the number that we have written here. So it's basically 1 times 2 times up to 2n. And also this one, 1 times 2 times up to 2n times 2n plus 1, then we multiply by 2n plus 2. Alright, we can see there is similarity with the 1 to 2n, so we can cancel this here. Okay, and finally we get the 1 over 2n plus 1, 2n plus 2. Okay, this one for the factorial part, so we can write it like this one to here. We have limit and approaching to infinity, -1 divided by this. Now we can solve this one because it's just a nice way, and we have the n approaching infinity, this one infinity, infinity, and then 1 divided by infinity, we have 0, the basic concept. So we have the L equal to 0. Now we just substitute back into the row, 1 over L, 1 over 0, we get infinity back. From the value that we have the row equal to infinity, we know that the line is from negative infinity up to infinity. The cosine x is actually differentiable in all this line. So we can say that the cosine x is actually analytic for all real x. Thank you for watching. I hope this video can help you guys.